Now we had discussed how due to applied temperature, there is a change in volume that we have established. But why do we use specific liquid only? Specific liquid. As I've mentioned in my previous video, there are many substances which reacts to heat, but we only apply specific liquid while measuring temperature. The reason because all the liquids and solids has different expansion properties. Different expansion properties. Expansion properties when they come in contact with heat. When in contact with heat. So this is what we know of. But what we observe in gas is that all the gas has the same property, that is they expand uniformly, same properties. They expand uniformly with the applied temperature. So gas is directly proportional, or the volume of gas is directly proportional to the applied temperature. Now there was a scientist known as Robert Boyle. This is Robert Boyle. So he had a huge contribution in your ideal gas equation. Now we'll come into what is ideal gas equation. Robert Boyle. And the law he proposed was known as Boyle's law. Boyle's law. So let's understand what is Boyle's law. Now, Boyle's law came from the fact that when you apply a temperature in gas, the readings which is being shown is same for all the gas. So this is what you can understand from Boyle's law. And Boyle's law gave an equation that is PV equals to constant. Pressure into volume is equal to constant. And V upon T is also constant. When pressure is maintained equally for all the gases, then the change in volume will be directly proportional to change in temperature. Now physically, if you look, say suppose this is a container. This is my container. Now in this container, the pressure P is uniform. There is no change in pressure. So for gas 1, we have, if there is an increase in temperature, there will be an increase in volume. For gas 2, if there is an increase in temperature, there will be the same increase in volume. So it is constant. Now if we modify it, we will have, since PV is constant and what we had was pressure. If pressure is taken to be a constant term, then V upon T is also a constant. So this is equation 1 and this is equation 2. Now from equation 1 and 2, what I have, PV equals a constant, V by T is also equal to constant. So in place of V, therefore PV by T should also be constant. Now this constant upon calculation was PV by T. Now this is pressure, this is volume, and this is temperature. And this was equal to mu into R. This is equal to mu into R. Now what is mu? Mu is nothing but your number of moles in the sample. That is number of moles. Let's use different color. This is number of moles in a sample. So if you are taking this much volume of gas, so it will have a specific moles. This is a specific quantity. So this is the number of moles that is present, and this comes from your chemistry. The mole concept comes from chemistry, but what you can understand is for a specific volume, there is a specific amount of particles, that is specific moles of gas are there. So this mu is your number of moles in that particular sample that you are taking. And now R, if I want to define R is universal gas constant. This is universal gas constant. Now this whole equation is for ideal gas. Now when we talk about ideal gas, we talk about there is no intermolecular phase of, that is intermolecular attraction between one and the other molecules or atoms. So this is the equation, that is Boyle's law for ideal gas equation. Now we talked about zero temperature, that is minus 273 degree Celsius. So this is what zero temperature is. Now how did we arrive at minus 273 degrees Celsius? Because physically you cannot, right now with the technology that we have, you cannot come to this degree Celsius. This is way too low. And what it is told, that if you arrive at this particular degree Celsius, the volume is zero. The volume is zero if you arrive at this particular temperature. So how did we come to this particular equation about absolute zero temperature? The concept of absolute zero. So this concept came from Boyle's ideal gas equation. So if you plot a graph, say suppose this is your pressure and this is your temperature. Say suppose this is your pressure and this is your temperature. So now this is the, if we plot this graph, now pressure versus temperature. So pressure and temperature is directly proportional. P is directly proportional to temperature. So if you increase the pressure, the temperature will increase. So if you increase the temperature, pressure will increase. Now logically also, if you come to think of it, while increasing the temperature, there is an increase in volume. So if there is an increase in volume, so you will experience pressure. Now this is pressure and this is temperature. So we have a straight line. Now if I pull this back, when is the pressure zero? So for ideal gas equations, I have a line. Now if I pull this backward, my temperature comes to, when is the pressure zero? When is pressure zero? When volume is zero. So when is the temperature, that is what is the temperature relating to zero pressure? And while plotting this graph, we have minus 273.15 degrees Celsius. So this is the origin of absolute 0 degree.